So this is the first kind of multi-step problem that we're going to have in here. In this one, it really tells you exactly what to do each step of the way. So for this, it says first up you're going to balance this here. And then it has you do some conversions like we did in previous problems. Now there is one typo in here, which is it says given 3.75 moles of calcium, how many liters of calcium oxide are produced at STP? What's wrong with that? What's wrong with that? Look at the state of matter. Yeah, is it in liters? No, it's aqueous. So this doesn't make any sense, but just to try out this problem, we'll just keep it the way it is, just so we can do a liters conversion here. But obviously, if you're converting something into liters, it should be a gas, all right? Okay, so let's roll through this. Did anybody balance this already? What do we need to do? Good. 2 in front of the AG. All right, so we balance the equation. Given 4.96 moles of calcium, how many moles of Ag2O, or silver oxide, are required? All right. So what do we do here? What goes on the bottom? Good, moles of it. Moles of calcium, right? Because we need to cancel it out. And then what's going to go on the top? Yep, what we're looking for, the moles of the silver oxide. All right, how many moles of each of those? 1. This can happen. It makes the math really easy, right? You're not going to mess up sig figs. 4.96 moles Ag2O. Okay. Great. Now, let's do the next one. It says, given 3.75 moles of calcium, how many liters of calcium oxide are produced at STP? So we're just going to do this as if it was becoming a gas, just so we could try a problem. Okay, so we set it up, right? What do we do first on the bottom? Good, moles of calcium, right? And then what are we going to put on the top? Okay, good. Yeah, moles of calcium oxide. Because don't forget, you need to do the switch first, right? You need to go from calcium to calcium oxide. So it isn't something new in this chapter. All right, what are the coefficients for these both? 1, all right, so that stays 1 and 1. But we're not done. What's going to go on the bottom now? And what goes on the top? Yeah, the liters, right? We're going to liters, so it'll be liters of CaO and 22.4 liters of those calcium oxide. All right, so now we just multiply. And you guys tell me what you get. Go ahead. 84.0, right? Good? It's not bad. All right, and the last one. Given 5.55 moles of the silver oxide, how many grams of silver could be produced? So it's very similar to the one up there where we're doing something new. So give it a try. Why don't you guys try that one? Okay, so we start with 5.55 moles Ag2O. What's going to go on the bottom? Good, moles of Ag2O. What's going to go on the top? Good, moles Ag. How many of each? Oh, okay, yeah. 2 and 1, good. And then what are we going to convert it to? What's going to go on the bottom? Good. 1 mole of silver. And then what's going to go on the top? What is it, 87? Okay. So we are going to then multiply, 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 get a really big number, but we're going to have to round it to how many sig figs? 3. Okay, so what did the calculator give you? Like 11 something? Okay, so that has 4 sig figs, right? And then we have to round it, so we're going to round it to 3 sig figs, but that has 2 sig figs, right? So, Tiffany, what do we do?
A line over the first zero.
Yeah, you can put a line over the 0 right here, which means this first 0 is significant, the 10's place, and then we know the 1 and the 2 are also significant. What else could we do to show that it has 3 sig figs? Shayla? Yeah, let's put it in scientific notation. So, that would be 1.20 times 10 to the third, and what is this, grams? Grams of silver, or up here it would be the same thing, grams of silver. So either of these would be fine, completely fine, all right? You could even convert it into kilograms if you wanted to, but that's just getting crazy, right? Okay, any questions with any of that stuff? Now we're good?